think we're ready to start. Okay, so Passkeys, an exciting new feature, even though not too new. That's been widely adopted by, it was actually pioneered by Microsoft, and then it's been adopted by both Apple and Google. And so I'm almost positive there's going to be a widespread adoption of passwordless authentication across mobile and desktop and any other devices. And I'm guessing in a year or two from now, we're basically get used to using these things instead of remembering passwords, having password managers, and juggling with all that stuff. However, what's really interesting about the technology and the standard behind it is that it's not really new. The technology that allows this has been around for a while, at least as long as crypto is around. It's just these big companies, it took them some time to realize the potential behind it, and also to market this in a way that is more digestible for users that aren't really into crypto. Some users that might be even reluctant to use anything that has crypto in the name, and yet the technology is there and it's the same, and why not take advantage of that? So basically what this is you can register and log in to any website without having to create a password. You can use biometric authentication on your phone, your computer. You can use your fingerprint, your Face ID, whatever it is that you have on your device to authenticate yourself to that website. But that's only after you created your credentials. To create the credentials, I'm actually gonna go through a demo here. So Passkeys is kind of the name that Apple, Google, and Microsoft gave it, but the standard itself is called WebAuthn, and you can read more about the API behind it that browsers currently support on the MDN Docs website. But basically, let's say I am Bob and I want to create an account on a website. I just need to give a username. It can be an email address. It could be anything that identifies you. Then I click register. And then what happens next is, depending on the device and the browser that you use, you're going to be offered to basically provide a way that will create a key on your device. So if it's Apple, it's going to create a key in your iCloud keychain. If it's Google, I think it's called Google Password Manager, the app that they're using. You can even use a USB key. For all I care, you could use a Trezor to store that key, or you could use a Yubico USB stick, that like it says here. So for now, I'm just going to use the camera on my iPhone. I'm going to scan this. And then on my phone, it will just offer me to create an account for Bob. I'm going to authenticate with the Face ID. And there you go. Now, that's all it took to create an account. So now there is a record. And I'm going to dive deep into the underlying implementation, at least somewhat schematically in a little bit. But now there is a record. There's an account on this website for Bob. So registration complete. So I go back to this website. I want to log into my account. I click now. I also enter my username and I click authenticate. It offers me the same choice to pick a device that is where I have my security key. I'm also going to scan with the same phone, or in case of Apple, it's basically any device that you have the same iCloud or Apple ID signed in with. So I'm just gonna sign in by scanning this QR code. Again, biometric authentication with Face ID. And there you go. Now I'm logged in. So this is all it took for me to log in and create an account by just using my phone. And again, the phone is not the only option. You can also use a USB Fido stick, a YubiKey. You could use your Trezor crypto hardware wallet. And to me, this is really exciting. And that's because, and again, you can get more familiar with the underlying implementation by reading the documentation. But there are already a number of pre-built implementations that you could just plug into your website on the server side as well as on the client side, and just to have Passkeys support. But what's really interesting is you're gonna hold on a second. I need to grab my Apple Pencil so I can sketch it out. Be right back. Okay, I'm back. So, as I was saying, what is really interesting is how the whole thing works and how it's basically the same sign in with your wallet like we're the Web3 people are used to doing with MetaMask, Ledger, or Trezor, or whatnot. And this is how it... Okay. All right. I'm curious if this is being streamed now that I'm mirroring my iPad, but let me check. I think it is. So this is what happened with what I just did, the demo that I just went through. This is what happened. As I was registering, right? I gave them my username, which is something that they store on their server, and that's some sort of a user identifier. Along with the domain name, so this registration process is specific to the domain. So in that case, it was WebAuthn.io or something like that. And then I passed it to my browser. So I just passed it to that WebAuthn API in Google Chrome, but the support is there for any major browser. And afterwards, what happened is that I scanned that code with my phone, and it created a public key pair. It's exactly the same public, or not exactly, but similar to a public key pair where you would create an Ethereum wallet. You'd have your public key, you'd have your wallet address derived from your public key, and then you'll have the private key, which you, if it's in case MetaMask, then that would be kept in MetaMask. If it's a hardware wallet, it would be kept on your physical hardware wallet. But it basically created a public and a private key pair. And then what happened is that, so this, let's say this was my device. What happened is that the public key over here was then sent back to the website. So now they have my user ID and a public key, and the private key was created and stored. In this case, it was stored. In case of iOS, it is stored in your iCloud keychain. So it's securely stored, it's encrypted on the device. Apple does not have access to it. You don't even have access to the actual private key. As far as I'm concerned, you can just export it because that poses security risks. So now you complete your registration and you end up with a new private key created for that specific website, and the website gets your public key. Okay, so far so good. So what happens then when you log in is that the website, in this case WebAuthn and.io, creates, I think they call it a challenge, which basically is, let's say, when you log into your OpenSea account using MetaMask, it's pretty much a similar process there. Well, you have to sign a string that OpenSea generates with your private key. So they give you that challenge, which is, for all we care, is just some bytes of information, and then you then scan the QR code and sign it with your private key that you had associated with Bob for that domain name. So you sign that, and then send the signature back. So then you end up with a signature here. And then you send it back to the website. And remember, they have your private key from when you registered. I'm sorry. Excuse me. They have your public key. Nobody has your private key except for your authenticator device. So they have your public key. And so they use a public key to verify if you indeed created the signature. This is exactly like MetaMask signing works. It's exactly like signing a transaction in Ethereum works and other blockchains as well. So upon successfully verifying that you were the one who signed their challenge, that the signature provided is legit, you're then logged in. And so your assertion is approved by the website you want to authenticate to. So as you can see, the technology is basically what we have in crypto. It has a really nice use case, which makes, registering accounts without password, reducing the risk of leaking or data breaches on the servers of where the databases are. Let's say you're logged into a website and then their database gets hacked into, and then you're kind of, it's a security risk. But if they don't store any password, all they do store is your public key. Even if that public key is as public as it can be, like they can publish it on their website for all you care, and it's still not going to allow anyone to gain access to your account and your data, because the private key is not shared with anyone, which is great. I think it's a really nice use case. For some reason, I don't have my mouth. Where is that thing? Oh, yeah. So if you want, you can try again here. There are some libraries for TypeScript, Go, Ruby, Python, if you want to play with that. And again, this is game